In this video, we're going to start to learn about circuits. So the first thing that we need to learn about circuits is how to draw schematics. So a schematic is basically a simplified representation of an electronic device, okay? So here we've got one of the simplest things. It's just a lamp, right? So the lamp is hooked into an outlet here, okay? So this represents the outlet or the source, okay? So this is the source of the voltage, okay? And then you have the wires that go to what is being powered, okay? So this is what's being powered. This is the resistor, okay, or the light bulb filament, okay? And then here you have the switch, right? So this is here, we turn it on and off, okay? And when the switch is open, the circuit doesn't work, and then when you close the switch, then the circuit starts to work, okay? Now, whenever you look at a schematic, we look at it and the direction of current is in this direction, okay? It's always left to right, like clockwise, okay? And so if we look at the source, then what does that mean? Remember, it's the opposite the flow of electrons is what the current is. So this must be the positive side and this would be the negative side, because the electrons then would be going this way and therefore the current is going opposite. Okay, so that's just some basics. Now, when we build an electrical device, we are limited by the voltage sources, right? So in your house, you have an outlet, it has 120 volts, okay? So, you only have one voltage source. However, we want to have different amount of energy coming here, right? So coming through our resistor. So when we build electrical equipment, there are two different ways to organize resistors. One way in which we can decrease the current and therefore decrease the amount of energy that's leaving this, or we can increase the current and therefore increase the amount of energy that's coming through this. Okay, so there's really just two different ways of organizing things. The first is when we put resistors in a series. So in this case, you would have one resistor and then another resistor, like this. Okay, so these two are considered to be in series, okay? Something that's in series, the current only has one path to follow, okay? It doesn't split off anywhere. All of the current is happening at the same time, okay? So in order to calculate this, the current, we need to know the total resistance, okay? And when the resistors are in series like this, the actual total resistance is the sum total of all the resistors, okay? So, and that sounds kind of redundant, but it's R1 plus R2 plus R3, however many you have, will give you our total, which is also called equivalent resistance, okay? So then to calculate the current, you would take, V equals IR, so you would take the voltage over R total will give you the total current, okay? Because all of those resistors are acting at the same time, okay? Because the current only has one path to follow, then at any point in the circuit, the current is the same. Okay, so if I were to measure it here or here or here or here, anywhere, I would always get the same current, okay? Now, the resistors in a series circuit, they have to share the voltage. So that means that some of the voltage goes here and some of the voltage goes here. So we actually share voltage, okay? So that means the voltage at 1 plus the voltage at 2 has to equal to the voltage total, which would be this, the voltage total, okay? And so on and so forth. If you had more than one, I really should have written it like this, okay? So for this case, this is a series case where more resistance is going to equal less current. So it's a way of slowing the current down and increasing the resistance, okay? And I'll do an example here in a minute. Now let's look at the other scenario. So this is where you would actually have the opposite effect. So where you want to increase the current and decrease the resistance. And that is something we call a parallel circuit. Oh, that was kind of a crappy drawing, but there we go. So this is parallel, okay? There is more than one path for the current, right? So it can split here and it can go here, okay? So these, as the resistance is actually going to be less. So how do we calculate total resistance in this situation? Well, if this is R1 and this is R2, the way that we calculate it is we take the inverse of the resistance plus the inverse of the other resistance, you know, and so on and so forth, will equal 1 over the total resistance, okay? Now, because each one of them has the same loop to the battery or the source, in this case, voltage at any point is equal, whereas voltage before, remember, had to be shared in a series circuit. Here, voltage is equal, okay? Now, because the current can split off, in this case, the current will have to add to some total current, right? So they can split into different. So the current here plus the current here would have to be equivalent to here where they split off, or here. Okay, so let me just do a couple of basic examples. Okay, so let's just say I had a very simple series circuit. So let's say I have a 9-volt battery and I have two. Okay, so here's 9 volts, and let's say I've got 2 resistors, one that is, let's just say they're both 3 ohms. Okay, so in this case, you know, typically what I want to find out first is what is the total current moving through this. So to get total current, I need total resistance. So remember, when they're in series, they just add. So I would have 3 ohms plus 3 ohms equals 6 ohms, which would be the total resistance, right? Then if I wanted to find the total current, I would just take 9 volts divided by 6 ohms. So 9 divided by 6 gives me 1.5 amperes. Okay, so anywhere, oops, sorry, amperes, not. So anywhere in the circuit, if I were to measure and I was to hook up an ammeter to measure, it would say 1.5 amperes. Okay, now let's see what voltage is lost here or used up there, and what voltage is used up there. Now it should be pretty obvious that, you know, they both have the same resistance. They have to share the voltage. They would share it evenly, so they would each get half. So this one will get 3.5 or 4.5, and this one will get 4.5. Well, let's just do it mathematically. Remember, voltage equals IR. So I would take 1.5 times 3, and that would give me 4.5 volts at each resistor. Okay. Now let's look at it if I were to have a 3 ohm and a 6 ohm. So 3 ohm and a 6 ohm, right? Again, we would add up the total, and we'll still have a 9-volt battery here. Okay, so we have increased the resistance, so we should actually decrease the current, right? More resistance, less current. So the total here would be 9 ohms, okay? And I want to figure out the current. Well, you take 9 volts over 9 ohms, and you get now 1 amp, right? Instead of 1.5. So by increasing the magnitude of the resistance, I'm decreasing the voltage, or excuse me, the current. Now if I wanted to see how much voltage was used here versus here, then I would just do V equals IR again. So 6 times 1, that would be 6 volts. 3 times 1, that would be 3 volts, for a total of 9 volts. Okay, now let's do sort of the same scenario, but now we have, instead of a 3 ohm and a 3 ohm in series, let's put them in parallel. So remember, the point of a parallel resistor is to increase current, right? So this decreases current, so we should get something higher than 1.5 when we put them in parallel, okay? So let's go ahead and just look at an example like that. So here you've got here, and then here. Okay, so this is 3 ohms and 3 ohms and 9 volts. So in order to figure out this, right, the total resistance here, I'm going to take 1 over 3 plus 1 over 3 equals 1 over R total, right? So 1/3 plus 1/3 is 2/3, and then we have to flip that upside down because we're going to take the reciprocal of it. So the total resistance would be 3/2 ohm. Okay, so then let's figure out the current. So 9 volts divided by 3/2 equals, so 9 divided by 1.5 gives me 6 amps. Okay, so now we know the total current in this entire circuit has increased, right? So we increased the amperes compared to the other one decreasing it. Okay, now if we wanted to know like how much was here, remember that the 9 voltage is being evenly shared, right? Or it has equal access. Each of the resistors has equal access. So 9 volts is here and 9 volts is there, right? So if I wanted to find the current in each resistor, okay, because remember it's going to split. Some's going to go here and some's going to go there. We're going to take 9 volts over 3, which would be 3 amps, right? And then remember this is going to be 9 volts over 3, 2, so 3 amps. So 3 amps would go here, 3 amps would go there for a total of 6 amps. Okay, so if I was to measure the current here, it would read 6. If I was to measure the current here or here, it would read 3. Okay, because of the splitting. All right, let's look at it in terms of a 6 ohm and a 3 ohm in parallel. So I've got a 6 ohm and a 3 ohm in parallel, again, a 9 volt battery. So here I'm going to have 1 over 6 plus 1 over 3 equals 1 over R total. Okay, so this would be 2/6, so it would be 3/6 total, and then you take the reciprocal of 3/6, so it would be 6 over 3, which is 2. So our total would be 2 ohms, right? So I did 1/6 plus 2/6 equals 3/6, and then that would be 6 over 3. So 2 ohms. So I have decreased the resistance. So if we look back over here, remember that when we put them in series, it was 9 ohms. But now I put a 6 and a 3 in parallel, and I've decreased to 2 ohms. Okay? So I could get the total current then, just take 9 volts over 2 ohms, would be 4.5 amps. Now remember that each one of these has equal access to the battery. So you're going to have 9 volts here and 9 volts here. Okay? So I could actually figure out the current in each place, and remember it should add to the total current of 4.5. So I just take 9 over 6 and then 9 over 3. So this is 3 amps is going to be here, and then that would be 1.5 amps. Oops, sorry, amps here. Now I'm sure you've heard the term follow the path of least resistance. Well, this is where it comes from, right? You're only going to have 1.5 amps going here, but you're going to have 3 amps going there, because more current is going to follow the path of less resistance. Okay? So these are very simple examples where we just either have parallel or we have series. But in actuality, most circuits are designed with a combination of the two. So in the next video, we'll look at solving circuits that are a little bit more complicated.